Are we on?
We're live.
Okay, so I should just remember.
We just go live
You
on, like,
live
Instagram.
Instagram.
I'll do it. Think I will?
So, we're just going to review chapter 17, and remember, chapter 17, basically what all this is the difference between metals and non-metals, and then some properties of the different groups. You will not be able to use a periodic. You will use a periodic table, but not one that has any. It'll just look like this, just a blank white periodic table. Okay, so you need to actually know what groups are what. So let's start with the metals. Where are the metals found?
In the middle.
Okay, they're found to the left of the stair step, right? And the stair step goes through here. Okay, and so these are the metals. Everything that is on this side, right, except for hydrogen, right? Hydrogen is not a metal. These are metals. Okay. All of these are metals. What are some properties of metals?
Hard.
Metals are dense. Okay. They are
metallic. Solid.
metallic.
Solid at room temperature? Yes.
So they are shiny.
Yeah.
Yes.
They're ductile.
Good conductors.
They are malleable.
Hard.
Wait, does that mean good conductors?
Is this on the-
Nope, they're good conductors.
Okay.
You've already done some of this. Okay. They're good conductors. When they form an ionic bond, do they gain an electron or do they lose an electron? They lose an electron. They lose an electron
Is this
in ionic bonding.
itself going to be on the test, like some of this stuff?
Yeah, this is all what the test is over.
Okay.
So metals lose an ion lose an electron when they form an ionic bond. So they become a positive ion. Okay. The other section is these are nonmetals. And there's some metal, like obviously we have metalloids, but this is the main division. Okay? So these are nonmetals. What are some properties of nonmetals?
Bad conductors.
They're bad conductors. Okay? So nonmetals. They are bad or poor conductors. Okay. They are they malleable?
No.
No, they're brittle. So they break easily. They're powdery or brittle. Okay. So they don't, if you hit them with a hammer, they're going to break.
They're at gas at room temperature.
Gas or
Liquid. Maybe not liquid.
solid
My bad.
at room temperature.
Liquid also.
Metals are solid at room temperature except for mercury. What else do we know about nonmetals?
Can I say something?
Yeah.
So basically, are they like? So basically, are they literally this? Basically, they're just complete opposite.
They're, in most cases, they're completely opposite, right? They're poor conductors, metals are good conductors. They're brittle, metals are malleable. They're gas or solid at room temperature, metals are solid at room temperature. So that's one thing they have in common. They also gain an electron in ionic bonding. So they become negative. Okay, non-metals.
Where's your hand?
Anything else we need to know about non-metals? Dave, put your phone away.
I'm showing metal.
They're not metal.
Daniel.
They're not shiny.
Remember when Mrs.
They don't have a lot of luster. Guys,
She's really
fellas, something to be quiet. Samantha,
Is bromine a liquid at room temperature?
bromine might be a liquid at room temperature.
Okay.
I need to look that one up. I'm not sure. Do you know for sure?
I think it is.
Okay.
I think that's what it says.
You're right. Bromine that's its unusual property, right?
Okay.
Is that it's a liquid at room temperature, whereas the rest of these are going to be, well, all of the noble gases are going to be gases. The halogens are going to be gases or solid. Okay, and like pure iodine is a gas at room temperature, I think. Right? So you're not going to need to know that kind of specific information about particular elements. Okay. What we'll do is we'll go over the groups, and you'll need to know the general trends of the groups. Okay. So,
Same with like the halogen.
metals and nonmetals.
That's all.
Okay. The main differences. Now what we're going to look at is within those groups, we're going to look at specifically, some of the more specific groups like the alkali metals, the alkaline earth metals, and the transition metals. Okay. So if we take a look at the alkali metals, okay, that's these right here, this first group. Okay. These are alkali metals. What makes the alkali metals unique compared to other metals? They have how many?
One.
Valence electrons.
Chemical compound.
One valence electron. And because of that, they have some interesting properties. They are violently reactive with water. So when they interact with water, and we saw that video, violently reactive, okay? And when they interact with water or oxygen, they're so reactive that they have an explosion. And the reason that they're so reactive is because it's really easy for them to give up this one valence electron. They want to get rid of it, and so they're very reactive. Are they found in nature as an element? No. Because they're so reactive, they are going to constantly combine with other elements in nature. So they're not found in nature as in their elemental form. They're found in compounds. No, they're found in compounds. So like, you'll find potassium in nature, but it'll be combined with chlorine or fluorine or something else. Okay. So if we think about the next group, okay, which are alkaline earth metals, and notice I did not include hydrogen in this group. Hydrogen is a non-metal. It's its own unique special group. Okay.
Wow, where is it special?
It is. Okay. So these are the alkaline earth metals.
So, is this going to be like a multiple choice questionnaire?
Grant will ask questions like that later. Alkaline earth. Okay? So, with these particular elements, what makes them unique? I mean, they're metals, but what makes them unique? Why are they their own group?
They're from the earth.
Okay, they're from the earth. They're all from the earth, technically.
Funny joke.
They have how many valence electrons?
2.
How do we know they have 2?
Those are in second.
They're in group 2. So they have 2 valence electrons. And they're also highly reactive. They aren't violently reactive like group 1 metals, but they are very highly reactive. If I had a question that asked, which group is the most reactive group on the periodic table, that's group 1, okay? The alkali metals. Alkaline are also very reactive, but not nearly as reactive as that first.
What about halogens?
Halogens are reactive, but not as reactive, because remember, when we get these, we'll talk about it, but they form what's called diatomic atoms. So it's F2, Cl2, Br2, I2, and that makes them a little more stable and a little less reactive than the group 1 elements. So alkaline earth, 2 valence electrons, highly reactive. Okay. So the difference between these two groups is their reactivity and the number of valence electrons. Alkali metals are more reactive than alkaline because, and this is important, you need to know this, because of the number of valence electrons they have. Okay. All right. So the other metal group is this one in the middle, the transition metals, and it includes all of these below the table, and it includes up to the stair step, basically. Okay. So in this range. It kind of, some of these are metalloids, and we're not going to get too concerned about metalloids. There aren't a lot of.
So they're in the middle of the table?
The transition metals are in groups 3 through 12. Okay, so transition metals are 3 through 12, and they have different numbers of valence electrons. They don't follow the same order as the main groups of the periodic table, the 1, 2, 3, 4, 5, 6, 7, 8. And so 3 to 12 are the group numbers. What makes them different than the alkali or the alkaline earth metals?
They're valence electrons.
Okay, so different numbers of valence electrons. Are they very reactive?
No.
No. So they're let's just say not very reactive. And they are also the more dense than the other, than the first two groups of metals. So they're a lot denser and they're a lot harder than the other metals. Okay? So more dense and harder. And these are ones that are used, as we've talked about, there's different groups within these. There's the coinage metals, which includes copper,
Nickel.
gold,
Nickel.
Nickel.
and nickel.
Yep.
Okay. No, that's copper,
Silver.
gold, and silver.
What does that
Nickel-
say? More what?
Nickel is in
The iron.
the iron triad.
That means 3.
3. And we'll talk. And we'll go back and look at those. Those are in our other notes. Meg.
How do non-metals form chemical bonds again?
So non-metals, if non-metals are forming chemical bonds with another non-metal, they're going to form what's called a covalent bond, where they're sharing electrons. But if you're having a non-metal combined with a metal, especially a group 1 or 2 combining with a group 6 or 7, you're going to have an ionic bond. They're going to these metals are going to donate electrons to these non-metals.
Wait, okay, on there, does that say more dense?
More dense, and they're harder.
Okay.
So both. Okay. All right. So let's quickly.
Someone.
Yes, Molly.
So are all the ones on the bottom all transition metals?
Yeah, they are included in the transition metals. Yep. Because they would go in between, right here, but they would go like from here to here. They just stretch the table out. So they're the inner transition metals. All right. So let's look at the other main 2 groups of non-metals. Remember, there are these mixed groups that we talked about: the boron group, carbon, nitrogen, oxygen. You'll need to know just a basic amount of information about those. What we took on the guided notes, what they're used for, okay, how many valence electrons they have. So if I said what, or I might say, what group, this is 13, 14, 15, what group 15 element is a metal? Which one of these is a metal?
That would be.
Bismuth.
Yep, that one.
Okay. Which is technically a metalloid, so I'd probably ask more like group 14, which one is a metal. And you could choose, I'd have a list, and you could choose lead or tin.
Lead.
Okay, they're both
I'm
metals.
confused.
So these are non-metals, and these are metals. So these are what's called mixed groups. There's some non-metals, there's some metals, and there's some what we call metalloids. But if I said, all right, what group 14, this is group 14 here, what group 14 element is a metal? And I had listed, your choices were carbon, silicone, germanium, or lead. Okay? Lead is a metal. Those that are touching this stair step are what are called metalloids. So if they're touching the stair step, they're part of what's called the metalloid group. Now some of them have more properties of non-metals, like boron has a lot more properties of non-metals than
So
metals.
boron, silicone.
Boron is technically a non-metal.
So silicone are all metalloids.
All my
Yes.
science.
These are metalloids. Okay? And we're not, like I said, there's not going to be a lot of questions about metalloids on the test because we didn't go over them a lot.
That's what I'm talking about.
Okay? So,
Halogens.
halogens, right? So these are the halogens. This is the other major group of non-metals. Okay, so there's the mixed group, and then there's these. And so these are the halogens. What unique properties do the halogens have
They glow.
that make them their own special group? How many valence electrons?
That'd be 3.
7 valence electrons.
Yep.
Okay? If you don't know that, you need to know that. You probably want to put your phone away. Stop playing Mountain Climber 7.
Actually, I'm on my notes, taking notes.
Okay, good.
Idiot.
Okay, so 7 valence electrons. What else do we know about halogens?
They glow.
They don't glow. What does halogen mean? Anybody remember?
They glow.
Salt
Salt.
making, salt forming. So they form salts
Like bath salt.
with what group? What group would they be most likely to react with?
Sodium.
Alkali metal.
The alkali metals. With group 1. Because they have 7 valence electrons, group 1 has 1. And remember, they want 8. So when you combine group 17 with group 1, you're going to have 8 total valence electrons. So they form salts with group 1 because of they want 8 in their full shell. That's important to know too. So they form salts with group 1. They also form diatomic
You didn't review your information.
molecules
Alright, Spawn, taking over now.
in nature. Okay? And what is a diatomic molecule? It's when you have two of the same element together. So remember, H, N, O, and these halogens form diatomic molecules. They don't exist just that. You never are just going to find a chlorine molecule just floating around by itself. It's always going to be two chlorines together.
Yeah, that's ridiculous.
First question. Okay.
Let me come back to it. Let me finish this so I can. So
Oh,
that when I
yeah,
upload
yeah,
it, let me come back to it. Let me come back to it. Okay. So let me come back to it, Grant. So let's finish up this so that I don't have so we can get this posted to the website for people who aren't here.
Yeah, that's what I'm talking about.
Okay. So helium
It's called work.
starts the group 18, and group 18 has a special name, and it is what?
Noble gas.
Noble gases.
Gases. Remember, noble gases are the least reactive
They're
elements
boring.
because they have a full outer shell. Caleb Worm.
Sorry, my bad.
So,
Are you gonna show this to future classes?
noble gases have 8 valence electrons. They have an outer shell that is full. So they are unreactive. They don't react with other elements because they don't need to have a full outer shell. And they are also their main use is that they glow
Light bulbs.
Because they're halogen.
when electrified. Okay?
It's too big.
Haha.
So when you run electricity through them, they glow different colors. That's what neon signs are made of.
So you just run like a bare copper wire through the glow.
No, they actually just have a tube of the gas, and they just run electricity through the tube, and that's how
Doubt
they,
it.
okay. So
Sure
a
did.
couple of other things. If you had to choose the most reactive element
It
on the
was
periodic
sodium.
Sodium.
Francium.
table, francium.
Ah.
This is the most reactive element because group 1 elements are the most reactive,
The sodium blows up.
and francium. Remember though, we watched the video, and as you go down, they get more explosive.
Ah, okay.
And francium, they've never
Can
done.
you sign me off?
So like that could be like a nuke.
Francium, and which element would francium be the most reactive with?
Fluorine.
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 Okay, so fluorine is going to be a very reactive nonmetal. Okay, would you sit down?
Oh, okay.
Not cool. Go sit in the hall. No.
I just asked you to sign me off.
Wait, what?
Very reactive nonmetal. Okay, so that should be the main points that you need to know. Like I said, again, you're going to need to know some basic information about like what is something that the oxygen group might be used for. So if I asked what element forms ozone when energy is added,
Oh, you told us this. It's like,
oxygen,
yeah.
O3. Okay. Which of the groups are some of the main components of fertilizer found in? If you look at nitrogen, phosphorus. So it's this group with nitrogen and phosphorus.
What group is that?
That.
1, 2, 3, 4, 15. It's 15.
Because nitrogen, you just have to know nitrogen and phosphorus are used in fertilizers.
Phosphorus.
How are we supposed to know what fertilizer is?
Just remember.
Dave, the
Remember-
periodic table is on your face.
So is this gonna be all that's gonna be on our desk?
Yeah, this stuff is what's going to be on your test. I haven't told you all the answers, but knowing these different groups is what you need to know. The properties of the different groups, and you need to know a little bit about how you're going to get combinations of elements. So you know that group 1 is going to react with group 17. What would group 2 react with? Most likely. Group 16, okay? The oxygen group, because you want to have a full outer shell of 8.
So you
Do it.
always wanted to add up to 8. So
Right.
anything
The outer
after
shell you
8,
want, that's what you would expect. Yep.
Do we get the periodic table?
You will get a blank periodic table.
Okay.
So then you'd say that.
The bonus on the test,
You should just get this.
the bonus on the test,
Since you did it.
the bonus on the test is going to be, I'm just going to have a list of elemental names and or chemical symbols, and you're just going to write down as many of those as you know for up to 3 bonus points. So if you want to take some time to just kind of look at it, A lot of them are pretty basic, but like if I have a C, you'll need to put carbon. If I have a magnesium, you'll need to put Mg. And that's just bonus. It's just bonus.
Bonus.
All right,
Done?
I have a question.
stop that and then